Hello and welcome back to the lecture on applied econometrics. So, we have been talking about probability distribution. So, we have learned the basic concept of what we call a probability distribution, how we constitute a probability distribution, what are the probability mass functions, probability density functions and so forth. Now, we are going to deal with specific types of probability distributions. However, to understand probability distributions, it is very important that we have ideas about these tools and concepts like expectation, variance and covariance that we will often use. Perhaps you already know some of it, but let me again sort of give you a brief summary of what these concepts mean. So, expectation, we will start with expectation. So, expectation as a term, it means to expect something, right. It's sort of like like I don't know what exactly is going to be the result, but I am expecting this. And we remember the idea of double structure of variable. We remember the idea of how frequency distribution and probability distribution differs. So, in frequency distribution you actually get the numbers, whereas in probability distribution you sort of predict, right. So, here we use the term expectation just as opposed to the term average or mean, which we use for a frequency distribution. So, for a probability distribution of a random variable, we use the term expectation to denote the mean or average. Okay. Now, how we do that? So, it's simple. In expectation we always use this. We use the value of the variable x, we use the probability of that particular value of that variable. So, we can write xi, probability xi, and we basically sum them up. So, where I multiply, so the steps are I multiply xi and pxi, and then I sum up summation of xi, pxi. Here pxi, probability of xi, is nothing but the weight. The weight that we use for any sort of averaging. So, here also we are using the weight, and we do that for all the possible values, okay, for all the possible values of the random variable. So, over all I, okay. So, this is what we call as the expectation of, let me write down, let me use a different color, so that this is something we call expectation of x, all right. This is how we derive the formula expectation of x, and if we sort of try to write all the components, so it is going to be, so I can write x1, x2, x3, x3 and so forth. Okay. So, here the notation usually, because it is the realized number. So, we are getting this number. So, these are small x's that we use and the corresponding small p's, whereas the x value, when we write expectation of x, that is going to be a capital X, because that is the random variable that I am denoting. All right. So, with this let us do an example. We already have done the example of throwing of 2 dice. So, just in order that we do not have to again redo the whole thing, I have written down the numbers for you. So, this is taken from the previous example. So, let us calculate expectation from this particular problem, and we will write down expectation of x. Let me use a different color. Expectation of x is going to be basically then the value of the variable and the corresponding probability. So, the value of the variable is 2 here, and the probability is, let me, 1 by 36. Okay. Then the second one, the value of the variable is 3 and the probability is 2 by 36. Third one, the value of the variable x is 4 and the probability of 4 coming is 3 by 36. The next one, the value of the variable is 5, the probability is 4 by 36. Similarly, this is going to be 6 into 5 by 36. The next one, 7 into 6 by 36. Then the next one, 8 into 5 by 36. 9 into 4 by 36. 10 into 3 by 36. 11 into 2 by 36. 12 into 1 by 36. Okay. Now, if we sum these things up, so we will get basically we will have 36 in the denominator and here we will be adding 2 plus 6 plus 12 plus 20. So, 2 plus 6 8, 12, 20 plus 20 40 plus 30 70, 70 and 42 112, then this is 40, 112 and 40 is 152, 152 and 36 is going to be 188, and then 30, 188 and 30 is 200 and what 218, 218 plus 22 is going to be 218 and 22 is going to be 240 and then 12, 252. So, we will have 252 by 36. Okay. So, if we get 252 by 36 and if we cancel things out, so you can divide numerator and denominator by 6, 4 2 and then you can again do it. So, 7. So, this is going to be the expected value of the sum of the two dice. Okay. So, when you basically all you are doing is basically averaging the values, whereas the average, the weight that you assign is the corresponding probabilities, all right. So, the same vein we can actually simplify the problem for you, and I can ask you, okay, so let us have one dice and where you have to calculate the expected value appearing after a throw of a dice. So, in that case, if it is a if you are throwing only one dice, so all the possible outcomes are going to be 1 2 3 4 5 6, that is it, right, and the probability for each of these is going to be 1 by 6, right. Now, if you have expected value of x is going to be summation of xi p xi, so then I am going to have over all I, so then I am going to have 1 by 6 plus 2 by 6 plus 3 by 6 plus 4 by 6 plus 5 by 6 plus 6 by 6. So, which means it is going to be I think 21 by 6. So, that is nothing but 3.5. Okay. So, this is how any problem you sort of deal you basically take the probability value as well as the value of the variable, okay, and then you get the average. Now, in the same way you can actually think about you can actually use the expectation formula for much wider use. So, instead of x having just the value, you can actually represent x as a function. Okay. So, how we can write that? If perhaps let us say you can write it as expectation of f x. Okay. Instead of x, you write f x, all right. And when you write f x, so then what you do is instead of x here, you write f x here. Okay. So, basically you will be writing f x I into p x I here. Okay. And if you sort of fx1, fx1 probability of x1, fx2 probability of x2 and so forth, fxn probability xn. Okay. Now, to give you an example, let us say the previous example only, if we just use here fx is equal to x square, let us say. Now, if I or x square, so if I use this x square, so if I use this formula and for this particular example, so then what I will get is, let me add another column here, let me use this. So, the value of x square is going to be 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121 and 144. Okay. Now, if I want to sort of get the expected value of x square, so what I will get is, so perhaps it is a better idea to use here the same screen. So, then the value of expectation of x square is going to be 4 by 36, then I will have 9 into 2 by 36, then I will have 16 into 3 by 36, then I will have 25 into 4 by 36, I need more space. So, then I will have 36 into 5 by 36, then I will have 64 into 6 by 36. Just a second, let me see if I match it. 1 by 36, 2 by 36, 3 by 36, 4 by 36, 5 by 36, 6 by 36. Oh, I just missed out one thing here, 49. Okay. Then I will have 64 into 5 by 36. Then I will be using, so this is 8, 81 into 4 by 36. Then I will have 100 into 3 by 36. Then I will have 121 into 2 by 36, and then finally 144 into 1 by 36. Okay. Now, if you, I am not really adding now, but if you add these things up, the value that you are going to get is 54.83. So, that is basically how you calculate the expectation for any functional form of x. Instead of just the x, you can represent the random variable in terms of any functional form. Okay. So, that is how you calculate this expected value. Now, one last thing about expectation sometimes that people may confuse is the difference that we see between expectation of x square and expectation of x of whole square. So, just note that these two are not same. So, here you are taking expectation of this function where the function is represented by x square, and here you are actually squaring the whole expectation value basically. And we will see the application of these differences in the next lecture. So, in the next lecture we are going to talk about variance and covariance, and we will also talk about the properties of variance and covariance. So, with this we end this lecture here. Thank you.